My name's Ted Young. I work at Lightstep, obviously, and I'm one of the co-founders of the Open Telemetry project, along with Ben here. And Ben, I'm sure everyone knows you as the CEO of Lightstep, but you have a deeper background in this, going back to your early Google days. Do you want to just give like a brief couple minutes about like what got you into this whole observability world to begin with?
Yeah, sure. And yeah, thanks for doing this to me, Ted. Ted and I have worked together for a long time, and we're good friends as well. I started at Google in 2003, and I was working on the ad system, which I really did not enjoy. And I ended up in a literally random, it's a longer story, but a random conversation with a woman named Sharon Pearl, who was a pretty distinguished researcher who'd come from Digital's research lab that kind of dissolved after the Compact merger in the late 90s. And she described what she was working on, and that she was doing like 5 things. And one of them was this prototype of this idea for like tracing across service boundaries called Dapper. And it was just a concept, like they hadn't really gotten into production. And it sounded so much more interesting and valuable than the work I was doing. At the time, my manager had 120 direct reports, not just that his org was, I was one of 120 reports. So he had no idea what I was doing. So I was just like, I'm just going to work on this other thing instead. And so that was 2004 or something like that. And then from that point until I left Google in 2012, I basically worked on observability. I mean, we didn't call it that at the time, but I built out their distributed tracing system, Dapper, and got it into production and tried to make it useful, and then built out Monarch, which is Google's essentially their time series database metrics monitoring solution. So that's what I spent most of my career at Google doing for the last 7 years there.
Yeah. And so when we get into why observability is hard here, like what fundamentally makes it difficult, I imagine these are things that aren't just problems out here in the real world, but these are problems you experienced at Google as well. So no matter how big or small your system is, these are the real problems.
Yeah, exactly. And I think when Ted and I were talking about this, we really wanted to frame it in terms of kind of first principles stuff, and that's the way that this is going to, hopefully that's what the discussion will be about, I hope it'll be interesting for people to think of it in these terms. But these are this is what why observability ends up being such a tricky problem, both technically and from a human standpoint, both human and technical problems.
Yeah, the real grist. So yeah, let's dig into it. So we're gonna go for about 30 minutes here, and then we'll have a Q&A at the end. There is a chat tool. There is a Q&A tool. If people do post questions along the way, I'll try to weave some of them into the conversation. Apologize if I can't get to them all while we're talking, but we will do a long Q&A at the end. So hopefully we'll get to everyone's question. But yeah, let's just start with the most fundamental. Like, why is observability hard? Like, what makes it hard?
Yeah, it's a good question. I mean, I think there's a technical answer which we can get into, but at some level, I think the problem is that the people who observability is usually discussed in the context of fairly large strategic software applications that are often facing some kind of transactional workload, either coming from like human beings, like, on a mobile app, or if you're, Twilio or something like that, you have a bunch of APIs that your customers hit. But in either case, you have a transactional workload that's important to your business. And there's that plane. And then you also have this plane of the system itself. And those two things, they do meet in the middle, but they're kind of orthogonal. And I think that that's actually a large part of why observability is so difficult. I have some slides about this that are kind of drawn from some scribblings I've done on Twitter that I might just run through quickly just to provide some context, because I think it's easier to explain visually than in terms of just talking. Is that cool, Ted?
Yeah, absolutely. I would love to hear more. I mean, I definitely agree with you. You've got the transactions, the actual work being done in the system, and then you've got the resources, right? That are right. The things doing the work.
Exactly. So in fact, those are the words I'm using here. So you've got transactions and resources. This is sort of like, I have three little prepared segments here that are very brief, just to kind of set some terminology. Okay, so what are transactions? I think, people know that word, but there are different definitions of it that sometimes conflict. And what I mean by transactions are just any request that comes into the top of your system, propagates through, if you're doing cloud native stuff, probably multiple services, if not dozens of services before it comes back to the originator at the top of the stack. These are the things in your application that actually do something. So if it's not, if your application stops servicing transactions, then your customers get really upset. If you're doing cloud native, these transactions are kind of distributed by design, which is to say that you have multiple different, separately maintained and operated services that are having to collaborate to satisfy the transactions. And I also would say transactions, and this is something that I think, to be clear, the industry has not kind of caught up to this reality, but they can be described at many granularities. Like, you could have a transaction described just in terms of, like, you can have a product management tool that just looks at transactions at the top of your stack, like in the actual mobile client or web client. You could have, commonly distributed tracing tools are operating at kind of layer 7 calls, like HTTP calls. But really, like, ideally, and we are not there to be clear, but ideally, observability would allow you to, at will, descend into the level of local function calls, or maybe in certain situations, even have the opportunity to understand how, individual lines of code or CPU instructions are, incorporated into these transactions, right? So at an abstract level, the transaction can go way up and down the stack. Typically, we actually, for production monitoring and observability today, we're stuck in, the top 2 of these, but occasionally you can get a little bit lower down. And telemetry-wise, transactions are usually described by distributed traces, so tracing and structured logging, where, logging where you have key value attributes to describe the path these things take. And I have kind of I took it out of this deck, but I've done webinars in the past where I talk about why tracing is eventually going to replace logging. It's a little bit of trolling, but if people ask for it in the Q&A, I have those slides in an appendix, but I'll skip that for now. The resources piece, this is, so I think transactions are clear. Resources, that word means different things, different people. So just to level set on what we mean, or what I mean by this, these are at the most abstract level, resources are things that transactions consume in order to do their work. And they also exist at many different levels of granularity. By definition, they're finite. So like CPU is a resource you might consume, memory is a resource you might consume, et cetera, et cetera. And they survive across transactions. And in order to make your system efficient, they're shared across transactions. So, and this is really, really important. If you didn't need to share transactions, share resources across transactions, everything would be a lot simpler. You would just provision a new resource for every transaction, or pre-provision it, and there'd be no issue. The fact that we need to have multi-tenancy within a resource between multiple transactions is what makes it difficult to build resources that can scale horizontally. And I have a rant here about serverless, where serverless promises sort of this idea that you don't need to worry about this, but you kind of do, at least from a cost standpoint. And they can also be described at many granularities. I would say all 4 of these things are a type of resource. The top level ones are the ones your CFO will care about. The bottom level ones are things that, only an engineer who's really on a mission is going to bother caring about. But like, ultimately, if you're trying to tune your system, you will need to care about things like individual mutexes and stuff like that. So there's a hierarchy of these, and they're typically, their health is usually measured with time series statistics or metrics. If it's a microservice, you might be looking at CPU and RAM. For Kafka, you might be looking at the lag that consumers and producers are seeing. For mutex, you might look at how long people are transactions are waiting on the mutex as an indicator of health. And these, like tracing and logging, also have a set of tags. And that's really important to pair the two. And finally, they're also hierarchical. So you'll see resources nested in this way. So Ted, does that make sense? Or do you have questions about this? Or do you think people might have questions about this?
Yeah, I do think it makes a lot of sense. I think the transaction part is very clear, especially when we're talking about web transactions, which for better or for worse, like you say, that's kind of where tracing is at these days. We don't necessarily have great. Well, there actually are tools like eBPF and tools for grabbing things at the more fine-grained like system level. But why are those not necessarily part of this picture today, or are they?
That's a really good question. I think I just literally omitted them from my list, but I mean, eBPF would fit in well here, I think. I mean, it's just a different, in my mind, is a different way of capturing some of the, well, I guess in eBPF's case, the network traffic coming in and out of services. So it's a different mechanism for instrumentation, but ultimately it's producing, hopefully anyway, data about transactions. My rant about eBPF is just that I love the idea, and it's obviously really easy to deploy because you don't have to re-instrument anything. But if you're using modern networking stacks, you're probably encrypting your traffic. So if you want to understand layer 7 stuff, like you want to understand application level tags, it's very difficult to do that in eBPF because you're sitting down like underneath the encryption layer. So it's like you can't see any of the traffic, right? So I've always felt like that's kind of the elephant in the room for eBPF. So I might mention that as an issue if you're trying to get things like, if you want to get something like a customer ID out, that's very difficult to do with eBPF if you're using TLS, which many people are using even inside of VPC for security reasons.
Right. And just real quick, some people are asking, what is eBPF?
Well, I forget what the E stands for, but it's like the new version of the more extensible version of BPF in the Linux kernel. Maybe it stands for extended or something. I don't remember. But practically speaking, eBPF allows you to write, essentially like sort of small programs that are installed in the Linux kernel to sniff around at the networking layer. And it's very flexible and it can do some really cool stuff. And it also runs with pretty low overhead. And so practically speaking, what people are excited about is that you can install an eBPF extension. Just, you don't have to like restart the VM or anything like that. You can install an eBPF extension and grab all sorts of telemetry coming out of the network stack at very low overhead.
So it's kind of like kernel tracing, but focused on networking.
Exactly. And it's really cool. And for point-to-point stuff, it's amazing what you can do. For tracing, it's so tantalizing because it performs well enough to work, but then there's this fly in the ointment, I think, around actually what data can you actually get out of it. It's a little hard to decrypt in many cases.
Do you think there's hope of being able to connect eBPF data up to like distributed tracing data?
Certainly a lot of people think so. I think there's a couple of projects that in open, we're both sitting on the Open Telemetry Governing Committee, and I think there's a donation from Flowmill, which was acquired by Splunk, of their code, the very sophisticated code to do eBPF tracing. And then I think there's also Pixie Labs, which New Relic acquired. They've also open sourced a lot of what they did. So those are the two kind of startups that had been doing the most work. But I have to admit, I'm not an expert on exactly where the boundary is, but I think that's, there's certainly a lot of excitement about it. I know Amazon's investing a lot in it.
Yeah, and I will like do a quick plug here. So Flowmill was donated to the Open Telemetry project, and New Relic and the Pixie people are interested in working with the same group. So there is now an eBPF group that's part of Open Telemetry that is looking at solving this problem. Like, how do we integrate eBPF into the same data stream and then hopefully be able to like correlate it? But like you'd say, it's kind of an unsolved problem, and things like TLS and encryption kind of get in the way of some of it. But
but it's enormously powerful in the sense that you don't need to make a single, you don't have to change a line of code, and it doesn't care what language you're using or anything. It's very principled in that way, which is extremely appealing. And for point to point, I think it's awesome. If you just want to understand peering information, it's amazing. Yeah,
great. So let's switch over to resources real quick. Oh, and some people are asking about the slides. I'm going to go ahead and say we're going to give people these slides.
Right? Yeah. For 3 easy payments of $19.95. No,
Yeah,
no, the
well,
slides are totally, there's nothing, yeah, don't worry about that.
yeah,
I'll share the slides.
there's a follow-up email and the slides will be linked to it from there.
Yeah.
Real quick question about resources before we move on. People are mostly, I think, when they think of resources, they think of virtual machines and computers, and utilizing, CPU and memory. And the more concurrent transactions you have, you'll eventually saturate memory and CPU, and then you need to horizontally scale to get more of those. But it's more complicated than that, right? Like you mentioned mutexes. There's these other kinds of bottlenecks you can hit, right? Where we're just horizontally scaling won't actually solve the problem. That's Penny, everyone. He wants to go outside, but he's not allowed right now. But yeah, could you talk a bit about like some of those other resource bottlenecks and where they're important?
Yeah, definitely. And yeah, CPU and memory are sort of the canonical ones, but I mean, anyone here who's running Kafka in production has probably experienced at least a couple of moments where you ended up with one of the many producers in your kind of system using Kafka had a bad day and decided to overproduce by 10x or 100x or something. And then that will flood the Kafka cluster entirely. And then everyone else who's using it suffers. I mean, that's like incredibly common, unfortunately, and really hard to, it's not Kafka's fault. It's just a really hard thing to manage. I think that's I'm just looking at the screen. That's an obvious example. For, mutexes, it may, you may think of this as mutexes. You may also think of it as like, oh, my MySQL database, which is still probably there for most applications somewhere, or Postgres or whatever, has like, some kind of table that's running slowly or queries are backing up. That's just another form of a mutex lock. At some level, your, SQL database has to lock a row and there's a mutex there and you're backing up on it. So I think that can take many forms. Right. Many times in a database, it will look like, a slow query or some backup of queries on a certain table or row of a table, but that does come back to mutex locks at some level. So again, that's just sort of a generalization of a situation where you have readers and writers on some piece of data.
Right. And this is why, besides a lack of infinite money, elastic compute and serverless aren't just the catch-all solution to this resource management problem, right?
Yeah, totally. And I mean, yeah, well, there's, as I said, there's a rant there. I not like I'm against them, by the way. I just think they're over marketed. I think it does have its place for certain types of applications, but the elasticity, I think, can be a little bit of an illusion because they often depend on things that aren't so elastic. And then you end up with a thundering herd of little serverless functions that are hitting some other resource. And then that becomes your new bottleneck. So it can just kind of move the pressure point somewhere else, wherever the stateful piece actually is.
Great.
Yeah.
Okay, well, why don't we dig into that a bit more? So we've talked about transactions and resources, right? But there's clearly something about how they interact in the real world that's like kind of the source of this difficulty. Could you get into like the details of those difficulties? And
yeah. So that really is the part that I really wanted to cover today. And I hope this is I hope this is interesting for people. I know there's another version of observability where you talk about metrics and logs and traces and stuff as the telemetry. And I can go into that if you want, but I think that's a little bit more, there's been more discussion of that, but I think this is really fundamentally what's happening. There's codependency between the resources and the transactions, and that's why it's so hard. So let's go back. Okay, so we have our resources and you have a bunch of transactions coming in. So the transactions are these little green things, and the resources are these blue things. And it's critical to understand that you have many, many transactions. I've drawn I can't count 8 of them here, but really it's more like 8,000 or 80,000 or something like that, right? You have a lot of transactions that are flowing through these resources at the same time. And you have a bunch of telemetry coming out. I think you have often tracing data coming out of the transactions. You often have metrics data coming out of the resources. And then in both cases, you have a set of tags. Like you have tags on the resources and tags on the transactions. There's a technical problem that I'll just describe briefly, which is that you have all this data, whether it's structured logs or tracing, and you have all this metrics data down here for the resources. And although they have some common tags, the data stores at the moment and the products that are used to actually analyze these things are often totally siloed. And that makes it really difficult, because if you're trying to understand how a set of transactions is affecting a resource or vice versa, your tooling needs to be able to join across on those tags, and needs to be able to do that in the aggregate. I don't mean like looking at individual traces in the trace visualizer or looking at individual time series in a metric visualizer. The system that you're using needs to be able to join across these two data sets, and it needs to be able to do so dynamically and efficiently to figure out how a change in the transactions is making a resource unhealthy, or how an unhealthy resource is affecting transactions. And that join is very difficult because there's a huge amount of data on both sides of this duality of transactions and resources. And then on the human side, which is actually possibly more interesting, these things are totally codependent. You have an unhealthy resource, then all the transactions going through it become unhealthy. If you have some massive influx of new transactions, that will make resources unhealthy, because everything has some scaling limit. No matter how you designed it, there's always a point where it will break. And then this is the key. From a human standpoint, the end users, your customers, they only care about transactions. They don't give an SHIT about your resources. That is like your problem as a DevOps engineer or whatever, is to manage your resources. But except for the nerdiest of the nerdy that want to read your postmortem, nobody cares about your resources. They only care about the transactions. But operators can only control resources. Operators cannot go in and say, oh, I'll handle this transaction for you, Mrs. Customer. Like, it's just like the only thing you can do is control your resources. So that's why I think you end up seeing operators with dashboards that are like basically resource. And then you have, business people and product managers who are saying, well, I only care about, what our customers see. And that's why observability, I think, is so hard, is that we have to find a way to make our observability about transactions when the only control surface we have is resources. And so you have to find a way to express that relationship. And I would also say that there's this weird codependency between the end users and the operators of a system. Like, we need each other. Like, we don't have any customers, then our business is destroyed. And if we don't have any resources, our customers are unhappy. But there's this codependency between the systems and the people. And I think that if you couple that with a vast amount of data, this is why observability ends up being both really interesting and really, really difficult because of these dual purposes. Does that make sense, Ted?
Yeah, I mean, it's really, it seems to me, it's obviously they're interacting, like transactions use resources, but there's this complexity at scale, right? Where it becomes hard to predict how that's going to work. Like, you can try to plan it out, but the kind of resources that get used are kind of dependent on the kind of transactions that are going on at any given moment. And there's some fundamental emergent complexity that can show up there. That to me feels like where the crux of it is difficult, right? Just figuring out, say, what's actually going wrong isn't necessarily something you can just look at in the code or just look at in your deployment of resources. There's something about how they interact unexpectedly that makes observability difficult, or observing what they're doing and trying to determine what they're doing actually difficult.
Yeah, exactly. And I think a lot of the tooling that people are using for observability is still really like pretty much a glorified wrapper around like a single telemetry type data store. So you'll have like a logging wrapper, some sort of metrics wrapper, and maybe some sort of tracing wrapper, depending on your maturity. And that's very far from the level of integration that's needed from a data engineering standpoint to do this sort of analysis. And it's especially far from being able to understand these sorts of relationships. Can I just pivot quickly to talk about SLOs?
Yeah.
Okay, I'm just going to skip this. And I'm going to skip this too, but I do want to talk about SLOs. So if you think about this diagram again, I think SLOs are really interesting in this framework, and I think it's a kind of an elegant way to understand them. So an SLO is a service level objective. It's kind of like the SLA that you have with your customer, except it's sort of an informal contract between any service, which I would call a resource in this case, and its immediate consumers. Those consumers might be an end user if you're at the top of the stack, but if you're in the middle of the stack, the SLO might just be about whatever other services are sending you transactions. So an SLO is it's a goal about a set of transactions. So your goal will be about the percent that are successful or the percent underneath some latency threshold or both or whatever. And there's scoped to a set of resources. So you might say this SLO applies to this microservice, or this SLO applies to this database, or this front-end load balancer or something like that. So the SLOs are goals that are both about transactions and a set of resources. And in that way, I think of an SLO, I was talking about there's this duality. I think that one way to think about SLOs and why they're so strategic is that they actually are a way to basically create a contract about how a set of resources is going to satisfy a set of transactions. And so in that way, it's a way of addressing both of these different planes and creating some kind of mutual accountability between the sets of people, the end users and the operators. So I think it's an interesting, this resources and transactions framing is a nice way of thinking about why SLOs are valuable for an organization.
Cool. And are these like, when you think of SLOs, are these just fancy alerts? Like how do they actually show up in your day-to-day practice?
Yeah, I mean, I think there is, there's some good practice around setting up alerts on SLOs, but and I know, Ted, you know the answer to the question that you're asking here, but I appreciate the platonic dialogue. They're also helpful in that you can set a budget for the percent of the time that SLOs can be, the percent of transactions that can fail your SLO. It's not like you strive to have 100% success rate. So you want to have, well, whatever it is from a business standpoint, 99.9% of the time you want to satisfy your SLO or what have you. And that's really helpful because it allows you to continue to innovate, because usually when you push changes, you're destabilizing your system. So it gives you some sense of how risk tolerant you can be with pushing new changes, and creates, again, an agreement between the people trying to develop the software and innovate and the people trying to keep it reliable. Because we all know the most reliable thing to do is never to push a new change to your system. So it helps to mitigate that, that tension.
Okay, cool. So with our remaining time, I'd love to ask you some questions about solutions here and then pivot to just doing straight Q&A. So it seems when it comes to actually observing these systems, I think you've laid out the problem very, very clearly. There's one aspect to doing this well, which is you mentioned all of this data being tagged and kind of correlated. So you need to actually have structured data coming in, right? It seems like your metrics, your traces, all of this information, your resources, there needs to be a way to actually have data coming in that's structured enough that you can do these correlations. And then there's the actual statistical analysis that you can do on them on the backside. And so I'm wondering if you could just talk briefly about like that structured data and what it is. And then like, what are like these, what kind of analysis tools do you think are great in terms of actually taking this data and using it to solve these real world problems?
Yeah, totally. It's a great question. And I would say that, a lot of the structure can be inferred automatically, especially about resources. You can grab that from configuration or, runtime, the runtime environment, things like that. The transactions, I think, are where you end up wanting some level of deliberate instrumentation somewhere in the stack to say things like, if you're in a multi-tenant system with many customers, you might want to know what the customer ID is so that you can figure out if one customer is being affected more than others or is causing a problem more than others or something like that. And I think, we're moving towards a world where we're getting closer to having that being dynamic, even for, pretty high cardinality attributes, like customer ID or even like, session ID or something like that. So anyway, I think that there's a lot of value in that. One of the main value props for tracing specifically is that you don't need to repeat that instrumentation over and over again. I think the pattern we often see is that people who are doing plain old logging or structured logging will have to pass the customer ID around manually and include it in every logging statement. That's basically like doing the hard part of tracing manually, which is really silly. I mean, it's much more sensible to pass the context around once for tracing and then log the customer ID once at the top of your stack and then allow the tracing system to do the join across the transaction. And then the customer ID is essentially applied to every single event in that transaction. That's the point of tracing. So I think the instrumentation burden is much lower if you are actually able to leverage a tracing solution to do that join and that assembly of the transaction for you.
Awesome. And in terms of like actually doing something useful with the data, like are there techniques that you think are like cutting edge or really interesting? You mentioned it's not just about looking at the traces, looking at the metrics, right?
Yeah, I mean, this isn't meant to be a Lightstep advertisement, but since I do think we've done a bunch of things with Lightstep that are very interesting in this regard. The main thing I would say is that the steady state of a system, it can be very complicated. And there are a lot of surprising things that are happening to anyone if you're looking at a distributed system. So what you really want to be able to do is understand changes in the system. And Lightstep has spent a lot of effort in R&D in understanding changes. And we have this change intelligence functionality that we've worked on where we're able to look at not just a single transaction or a single resource, but thousands of transactions and your entire system at 2 points in time when things are healthy and unhealthy and look at the statistics and how they've changed between those two data sets. And I think that has actually been very helpful at reducing the search space for operators when they're trying to investigate either an unplanned change or if they're trying to plan an intentional change like a deployment and they want to ensure that it's not damaging anything in other parts of the system.
Cool. Yeah. I have like a pet theory on this. I'm curious if you agree, like what these tools we're building do, and I agree they're great, is when you're operating a system and trying to mitigate a problem, there's kind of like two parts. One is figuring out what is going on, like what correlates with what. And then there's remediating the actual problem. And I know in my own experience in the past, I've just had to spend a huge amount of time collecting the data, actually like collecting the data, going through it, finding those correlations. In the past, when my tools were kind of all separated out, it's like I had to be the computer in the middle trying to connect all of those dots. And there's an aspect of like understanding the data from like a subjective standpoint and identifying what is relevant and what is a root cause. And I believe like the human will always have to do that. I'm not bullish on the idea that computers will be able to like root cause things for us, but it does seem like the amount of time we can save by having the computers do the legwork of just presenting the correlations, presenting the associations to us. That to me has started to allow me to just like move through things so fast that I can focus on the human subjective part. I'm curious, do you agree with that statement? Do you see that as like where a lot of the value is?
Yeah, I mean, I think computers can remove a huge amount of toil and can also make observability at the moment still feels a bit like an expert system, I think, for many organizations. But I think observability, when done right, can make operation something that requires way less training, both about the tooling and about the system that you're in. If you're in a distributed system, you shouldn't have to find the principal engineer who's been at the company for 10 years to help understand an outage, and that still happens all the time. There are a lot of organizations that would be totally up a creek without that principal engineer. And I think a lot of the goal of observability tooling is to make that person less of a necessity for triaging outages and things like that.
Awesome.
I know we have a lot of questions. I was just going to say, yeah. I'm free until like 5 until the next hour, until 55 past, and I'm happy to stay on and do as many of these as possible and send out the recording and stuff like that. I know that the webinar is advertised as half an hour, but the questions are really good, and I'd be happy to spend time going through these. So.
Yeah, let's do it. People feel free to continue posting questions in the Q&A tool. We'll try to get through as many as we can. If someone does have to log off, this is recorded. You will get a link to it. So even if you have to leave, still, feel free to post a question. All right.
And also, if you have feedback about the format or what we're discussing, we're all ears about that too. It'd be we love talking about things that are useful for people or interesting or both. So that's also welcome.
Yeah. You can definitely always hit me up on Twitter. I'm gonna put my handle into the chat real quick. Hosts, panelists, everybody. BHS, people want to see you on the Twitter? Is that a thing they can do?
That's a totally welcome thing. There, I did it.
There we go. Okay. So just kind of rolling through these questions from the top, we've got a question from Matthew Collier. I'm interested in hearing about sampling versus 100% data collection strategies. I believe this may be a differentiator for Lightstep, and I'd be interested in hearing how Lightstep accomplishes this objective. I know it's not a Lightstep talk, but I do think this sampling aspect gets to some interesting stuff.
Yeah, it does. It's a good question. I mean, I think it's true that a lot of Lightstep customers are pleased that they don't need to do any sampling of their tracing data in order to use as part of using Lightstep. If we go back, I'm not going to represent it, but if you remember the slide where I talked about the different levels of granularity for transactions, when you get down to local function calls and CPU instructions, I can tell you that there are 0 customers of Lightstep that send every CPU instruction to Lightstep. So there's always some kind of limit. And the way I actually see the stuff evolving is more like you want to be able to emit as absolutely enormous amount of telemetry at reasonable cost. And the more telemetry you can send to your observability tool or vendor, the higher quality of the analysis can be. So I think with Lightstep, the way I actually think of it strategically is just that we've spent a lot of time on data engineering and building out our own technology in order to, for $1 of cost, I think we can absorb 10 to 100 times more data than most other folks in the space. And that's why a lot of our customers can run in a quote unquote unsampled state. But there's also this question of the level of detail. And my goal is actually to get it so that the level of detail in analysis gets even higher than it is today, where typically there's a couple of data points per HTTP call. I'd love to get to a point where at least for some percentage of the data, we can get really, really, really specific so that the analysis we're doing in the aggregate can refer to those sorts of more granular things. So I see it really as just there's you want to have a telemetry data platform that is efficient and controllable and profilable. And that's what we've tried to produce from a data standpoint. And then you want a computational engine that can do that join across these different types of data to run the sort of analyses we're talking about today, where you can understand how end users are affecting resources and vice versa.
Yeah.
What is sampling is in this chat. Sorry, that's a really good question. And I should have explained that. The idea with tracing is that you record, depending on the level of detail, the path a single request takes across your entire distributed system. Great. The problem is it generates a huge amount of data, really, really huge. And with Dapper at Google, we published a paper about that. In Dapper, we ended up only actually recording 1 out of every 1,024 transactions. And the other 1,023 were just literally dropped, like there's no data emitted whatsoever. And so the idea with sampling and tracing is that you don't sample like locally, you sample globally. You take either the entire transaction or none of it. And that practice, for better or worse, became somewhat common in tracing because of that paper, I think. It turns out if you read the paper, like the reason we did it at Google really doesn't apply outside of Google. And we also was written in 2005 and things are different now. So it's not really necessary in the same way that it was then to protect the system. But anyway, it's a very common practice for better or worse right now.
I think there's maybe a point that people miss partially because they think of sampling as this head-based sampling, where at the beginning you're just, rolling a 1024-sided die. If it comes up a 1, you collect a trace, otherwise you drop it. But something we do at Lightstep, and I imagine other systems do, is sort of this like tiered model of storing data, right? Like you want to collect everything for a certain amount of time if you can, but you don't necessarily want to store everything forever, right? So there's these more complex sampling strategies you can do around having enough data to do certain kinds of analysis, and then just like the real cost at the end of the day is like long-term storage of everything forever, right? Do you agree with that?
Yeah, I mean, that can be really expensive, and I totally agree about the tiering, and it's kind of wickedly complicated. I mean, I can talk about, we could easily spend an hour talking about just sampling, because it's way more, it's treated as a sort of binary thing, or maybe people start saying, oh, there's head sampling and tail sampling. None of them, I think all of that doesn't do the subject justice. So maybe we should do like, let's have an hour we just talk about sampling, because it's
Sounds
really,
great.
really nuanced. And I think the thing that drives me insane, which I will just admit to you right now, is that it often becomes this, we deviate very quickly from like the purpose of observability in terms of, solving business problems. And I think a discussion of sampling in terms of the business purpose of observability could be really interesting. So.
Yeah, well, that sounds like a great webinar. So I'm seeing some +1s for that. So maybe we can get that on the books.
Yeah.
All right. Well, let's move on to some other questions. Does monitoring health of resources include determining current volume of utilization and current utilization, whether or not current utilization is closer to a threshold value? If yes, does Lightstep enable to do the same? So I think this is a question about like volume versus thresholds, right? Like being able to notice when you're coming near some kind of threshold.
Yeah, I mean, you can definitely do that with Lightstep. I mean, again, I'm for better or worse, I don't treat these webinars as like a sales pitch. You could do that with lots of other things too. I mean, the idea of setting up thresholds for resource utilization is an old one and not a bad one necessarily. There's a little bit of a caveat around setting up alerting rules around resource utilization. Just because if you think of resources as broadly as we were talking about in the talk today, like, down to the level of mutex locks and stuff like that, there's just a lot of them out there, and you'll end up with alert fatigue very quickly, because usually when one thing breaks, a lot of things break, and then suddenly you have like alerts coming from all these resources, and you don't even necessarily know if it's affecting the transactional workload that you have, which is probably what your business cares about. I think SLOs are probably a better place to go if you're talking about actually spotting, problems before they become emergencies. But it's not a terrible idea to set up thresholds and some kind of, sort of like, not quite P0 alerting scheme around the most important resources, or the resources where you cannot scale your way out of the problem. Like if your database is on the largest EC2 instance you can buy, and you're close to running out of storage space or something like that, that would be a good thing to know about before you actually run out. So it kind of depends on what sort of resource and whether there's a way to buy yourself out of the problem if you have to. But yeah, to answer the literal question, yeah, you can do that in Lightstep. I'm not sure if that is something that sets Lightstep apart from the field, but you can certainly do that.
Yeah. So we have a couple questions that I think are related around just getting started. People are like, as a developer, where do I start? Another person asks, I have a lot of junior devs on my team who regularly complain about complexity. How should they approach complexity? At what scale is complexity and observability important? So how do I get started with this? And like, how do I approach dealing with all this kind of complexity?
Yeah, that's a really tough one. I mean, in the sense that I don't think I have a great answer, especially for systems that are already, if they've already been built out and things weren't done correctly early on, it can be, it's a process, probably a multi-year process to kind of mitigate that. But I will say, I'm somewhat happy about the fact that the quote unquote kind of digital native companies that were founded in the last 5 or 10 years and started off with Kubernetes and stuff, they often, because they're startups, would give their developers a ton of autonomy in everything, including like what languages they use for each service. You end up with a lot of heterogeneity. I have seen when enterprises have adopted microservices and Kubernetes and stuff, they've been a little bit better actually about coming up with some rules of the road and some kind of paved path. I don't really know what the paved path should be for any organization, but the single most important thing I would say would be to try to find as short a menu as possible of technologies that your teams can use to build your distributed system. Like the distributed system piece might be necessary just to facilitate high CI/CD rates and things like that, but that doesn't mean everyone needs to build their service with a different stack. It just makes it so difficult to allow for team members to move around, to allow for people to debug other people's problems and things like that if you're dealing with different stacks. And I'm not arguing which one is best, but I think trying to limit the number of technologies used in the overall system is a really wise idea. SLOs are the other thing I've said a couple of times, but I think that they're an important part of developing, a practice around like what a reasonable contract is for any part of the system and how it relates to the other parts of the system. But unfortunately, I don't think the SLOs are really, most of the SLO tooling out there, it is not friendly to beginners. And it also doesn't help you understand what a reasonable target actually is. So to be concrete about this, you'll have someone at the top of the stack will say, well, our product, let's say it's a mobile banking app or something. We don't want to have, we only want 1% of the requests to take longer than 1 second or something like that. Okay, so that's an SLO about performance. And then it calls down to many services. And at the bottom of the stack, you have some microservice way down there that's receiving lots of requests. And they'll say, well, we don't want to have more than 1% of the requests take longer than 2 seconds. And nowhere does the tooling tell them that like those two SLOs are in conflict with each other. Like this one at the bottom of the stack can satisfy their SLO and it's not going to be sufficient to satisfy the mobile app. And the tooling doesn't tell you that. Lightstep is working on some stuff on this front, which I think is pretty interesting. But if you really are going to have dozens of teams and they're all going to have a lot of SLOs, the tooling needs to help the teams understand whether the SLOs are consistent with each other or to suggest thresholds or both. Because right now it's kind of like, I think we all recognize the SLOs are an important part of the solution, but we're not giving DevOps engineers the tooling they need to set SLOs in a way that's, guided. It's just completely manual. And I don't think it's a reasonable thing for people to do.
Yeah. Do you have, we're getting some more questions about SLOs that I think might be satisfied by just a couple more concrete examples of SLOs. Do you just have some examples?
Yeah, sure. I mean, the classic ones are latency and error ratios. So it's like, what percentage of requests fail, like in the sense they generate a 500 error or something like that, and what percentage fall within a certain latency threshold. That covers almost everything. I mean, you can imagine SLOs about other things, but that's the lion's share of SLOs. And then the granularity of, are we talking about, all HTTP calls coming into a service, or are we only talking about certain high value APIs? I would certainly urge people not to make it about all HTTP calls. I try to make it about like, what is the purpose of a service? Like, what do its consumers actually care about and depend on from a business standpoint? And those like key methods are the ones that should have SLOs on them, because it's actually difficult to set a single latency threshold that's correct for all different, unless your service literally only does one thing. It's hard to set an SLO that's appropriate for all the many things that are being done. So I think it's better to make the scope something that has a specific business purpose, and to use that as the kind of level of granularity for the SLO.
Awesome. So I think a related, very good question is, what are some of the best business use cases in order to showcase ROI for implementing or updating tracing practices?
Yeah, I mean, if you haven't done tracing before and then you start doing it, you'll find a bunch of really painful, not painful, you'll find a bunch of massive wins on latency. So I've never seen a distributed system that implemented tracing, even in just part of the system, and didn't find something huge that was like kind of glaringly obvious in retrospect. The trouble with latency wins is that once you fix them, people forget after 6 months or a year, like that they were ever there in the first place. So if you want to have a more continuous victory with tracing, I think the key, it really comes down to whether or not your version of tracing is like looking at individual traces in a browser window, which is always going to be an expert system, or whether the tracing is actually informing some kind of larger analytical engine that can do things that are like less of a expert workflow. So, I mean, again, like it's just an automatic pitch, like you can't avoid it. But with Lightstep, you hook tracing up to Lightstep, and most of our product, you don't actually look at traces. It's more that you'll see that an infrastructure metric will spike. You'll click on it and say, oh, CPU spiked Y. And then we'll say, well, it turns out that one of your 30,000 customers quintupled their workload, and that's what changed. And we can determine that by looking at the traces, but you don't actually look at the traces. So I think it just depends on whether or not you're using tooling that can take the tracing data and make it useful in more bread and butter contexts, like looking at infrastructure metrics or trying to understand a bad deploy or something like that. So I think a lot of people are confusing traces with tracing. Like tracing as a practice can be much broader than looking at traces in a browser window. But I think that's where most people are stuck. I also saw a question around implementing tracing. Getting tracing implemented across an entire application is a long process. We never would recommend that, no matter what tooling you're using. You should probably start at like the router layer towards the top of the stack, and then go down to the 3 or 4 critical dependencies it has and start there. That's not going to be nearly as heavy of a lift. And then you'll see a lot of benefit from that. And that benefit can be used to justify further investment. But we have seen many organizations kind of die in the starting blocks because they try to do tracing across the entire system in one fell swoop, and that doesn't work. And it also doesn't work to say, well, this is a new technology, we'll try it way over here in this part of the system nobody cares about. And it's true that you're not going to do any harm if you go over there, but you're also going to have no benefit. So you'll implement tracing, people say, huh, okay, but no one's going to care because you don't really have any wins. There are no wins to be had in the corner of your system. So I think starting in the center is actually an important aspect as well.
Nice. Okay, so I think we have time for one more, and there's, I think, an interesting ringer of a question here. Someone is thinking about sustainability and the environment, and they're wondering whether SLOs and these tools can help us use our resources more efficiently. Do you think there's a case to be made there?
Gosh, I wish I did. Ted's like a card-carrying environmentalist. You used to work in environmental nonprofits in your youth. What do you think, Ted?
Well, I think there's definitely a case to be made that the more efficiently we use our computers, the less power they're going to need overall. So sure, at like a fundamental level, if you make your systems more efficient, then they'll have a smaller resource footprint. I do feel like there is, I think I would say my caveat is there's this issue I think we have with the way we look at resource consumption, which is the cheaper it becomes, the more we tend to consume more. So I think the solution is not necessarily going to happen there.
Yeah, I mean, I think it's a really, really good question. And I worry about this. I mean, if we could find a way to turn Bitcoin off, I think that's probably the single best thing we could do environmentally right now. But in our industry, not to start a war or whatever, but the biggest win, I think, from an environmental standpoint, and we did worry about this a lot at Google, and it kind of kept me up at night. I visited a Google data center once, and just like it finally just dawned on me what the scope of the energy usage actually was. It was hard to really comprehend it until I was physically there. I'm like, holy shit, So it's over allocation of resources. It's that you are so worried about getting, what things are fine until you hit 100%, and then it's like really not fine. So you always over provision. And I think that SLOs are helpful. Good observability is definitely helpful in understanding what you want to get to higher utilization. I think if you can find a way to get your elasticity and utilization above 80%, and stay in that realm between 80 and 100 steady state, that's actually pretty good. What you'll see, a lot of systems are running at like 20, 30% utilization because people are so scared of getting close to 100. And that's actually very wasteful from a money standpoint and from an environmental standpoint. So I think good observability can allow you to run your systems a little hotter in the steady state. And that's, it's a good thing for your CFO and definitely a good thing for the environment.
Awesome. All right. Well, that sounds like a fun note to end it on. Thank you, Ben, so much for doing this talk with me. Looking forward to doing more of these. And for everyone listening, you will get an email afterwards with a link to this video plus the slides. Hit us up on Twitter. Let us know what you think. And we'll see you at the next one.